In electronics, and by extension amateur radio, some numbers are very large, some very small. For example, we might talk about a frequency in gigahertz. 1 gigahertz is 1 billion cycles per second. On the other hand, we might talk about a capacitance of 10 picofarads. A picofarad is 1/1 trillionth of a farad. To make things easier to deal with numbers so large and so small, we use a set of prefixes to denote orders of magnitude. Giga, for example, is the prefix we use to denote 1 billion of a quantity. A gigahertz is 1 billion hertz. We use the capital G for giga, so we would write gigahertz as capital G, capital H, lowercase z. Mega is the prefix we use to denote 1 million of a quantity. A megahertz is 1 million hertz. We use the capital M for mega, and we would write megahertz as capital M, capital H, lowercase z. Kilo is the prefix we use to denote 1,000 of a quantity. A kilovolt, for example, is 1,000 volts. We use the lowercase k for kilo, and we would write kilovolts as lowercase k, capital V. Milli is the prefix we use to denote 1/1000th of a quantity. A milliampere, for example, is 1/1000th of an ampere, or 0.001 amperes. The lowercase m is used for the prefix milli, and milliamps would be written lowercase m, capital A. Micro is the prefix we use to denote 1/1 millionth of a quantity. A microvolt, for example, is 1/1 millionth of a volt, or 0.000001 volts. The Greek letter mu stands for the prefix micro, so microvolt would be written mu, capital V. Pico is the prefix we use to denote 1/1 trillionth of a quantity. A picofarad is 1/1 trillionth of a farad, or 1/1 millionth of a microfarad. Lowercase p is used for the prefix pico, and picofarad would be written lowercase p, capital F. On the test, you'll be asked to convert numbers from one prefix to another. Let's look at some examples. Question: how many milliamperes in 1.5 amperes? Answer: 1,500 milliamperes. Since there are 1,000 milliamperes in 1 ampere, multiplying 1.5 times 1,000 gives you 1,500 milliamperes. Question: what is another way to specify a radio signal of 1,500,000 hertz? Answer: 1,500 kilohertz. There are 1,000 hertz in 1 kilohertz, so dividing the number of hertz by 1,000 will give you the frequency in kilohertz. And dividing the number of hertz by 1,000,000 will give you the frequency in megahertz. 1,500,000 hertz divided by 1,000, therefore, equals 1,500 kilohertz. Question: how many volts are equal to 1 kilovolt? Answer: 1,000 volts. Since a kilo of something is 1,000 of something, a kilovolt is 1,000 volts. Question: how many volts are equal to 1 microvolt? Answer: 1/1 millionth of a volt. Since a micro of something is 1/1 millionth of something, a microvolt is 1/1 millionth of a volt. Question: which of the following is equivalent to 500 milliwatts? Answer: 0.5 watts. Since there are 1,000 milliwatts in a watt, and 500 is 1/2 of 1,000, 500 milliwatts is 1/2, or 0.5 watts. Question: how many microfarads is 1 million picofarads? Answer: 1 microfarad. There are 1,000 picofarads in a nanofarad, and 1,000 nanofarads in a microfarad. So 1 microfarad equals 1,000 times 1,000, or 1 million picofarads. The farad, by the way, is the unit of capacitance, and we'll talk more about that later. Question: if an ammeter, a meter that measures current, calibrated in amperes, is used to measure a 3,000 milliampere current, what reading would it show? Answer: 3 amperes. This question asks how many amperes is 3,000 milliamperes. Since there are 1,000 milliamperes per ampere, the number of amperes is 3,000 divided by 1,000, or 3 amperes. Question: if the frequency readout calibrated in megahertz shows a reading of 3.525 megahertz, what would it show if it were calibrated in kilohertz? Answer: 3,525 kilohertz. This question is about how many kilohertz is 3.525 megahertz. Since there are 1,000 kilohertz per megahertz, the number of kilohertz is 3.525 times 1,000, or 3,525 kilohertz. Question: which of the following frequencies is equal to 28,400 kilohertz? Answer: 28.400 megahertz. This question asks how many megahertz is 28,400 kilohertz. Since you are converting from kilohertz to megahertz, you have to divide by 1,000. So 28,400 kilohertz divided by 1,000 equals 28.4 megahertz. Question: if a frequency readout shows a reading of 2,425 megahertz, what frequency is that in gigahertz? This question is similar to the previous one, but we're converting from megahertz to gigahertz. Just like converting from kilohertz to megahertz, when we convert from megahertz to gigahertz, we divide by 1,000. So 2,425 megahertz divided by 1,000 is 2.425 gigahertz. Okay, now let's talk about decibels. When dealing with ratios, especially power ratios, we often use decibels, or dB. The reason for this is that the decibel scale is a logarithmic scale, meaning we can talk about large ratios with relatively small numbers. When the value is positive, it means that there is a power increase. When the value is negative, it means there is a power decrease. At this point, you don't need to know the formula used to calculate the ratio in dB, but you need to know the values 3 dB, 6 dB, and 10 dB. 3 dB corresponds to a power ratio of 2 to 1, 6 dB corresponds to a power ratio of 4 to 1, and 10 dB corresponds to a power ratio of 10 to 1. Let's look at some examples. Question: what is the approximate amount of change measured in decibels, dB, of a power increase from 5 watts to 10 watts? Answer: 3 dB. 3 dB corresponds to a ratio of 2 to 1, and because we're going from 5 watts to 10 watts, we're doubling the power. So we can say that there's a gain of 3 dB in this case. Question: what is the approximate amount of change measured in decibels, dB, of a power decrease from 12 watts to 3 watts? Answer: minus 6 dB. 6 dB corresponds to a ratio of 4 to 1, and a decrease in power from 12 watts to 3 watts is a ratio of 4 to 1. And because this is a power decrease, the value in dB is negative. Question: what is the approximate amount of change measured in decibels, dB, of a power increase from 20 watts to 200 watts? Answer: 10 dB. Increasing the power from 10 watts to 100 watts is a ratio of 10 to 1, and 10 dB corresponds to a ratio of 10 to 1. Well, that's the end of this lesson. Please take the quiz and continue on to the next lesson.